Hello, 8th grade math students. Today our lesson is going to be on scale factor and dilations. This was module 3. We ended up doing a project with that with a fish, turtle, or shark, if you recall. What I'm going to focus in on today is dilation and scale factor and enlargements, reductions, and how to simply take the ordered pair and either dilate it to enlarge it or to reduce it. I would encourage everyone to please write the notes as we go. It will definitely help you answer the questions at the end of the slideshow. Okay, so here's what I've got for you today. To begin with, let me remind you what a dilation is, and that is when you have a shape of some sort and it either grows or shrinks but keeps the same overall shape. So I tried to draw a little example down here. This is an example of a dilation. You have an original right triangle here, and if you dilate it by a scale factor of 2, then it's going to make it larger. It's going to keep its same shape, but it's going to be larger. The scale factor is the number the original shape is multiplied by to create the dilation. So the scale factor in this case I chose was 2. So if this little side here was 2 centimeters and I dilate it by a scale factor of 2, what I'm essentially doing is multiplying them to get my new figure. So this side, the matching corresponding side here, would be 4 centimeters. Now, something to talk about before we begin is that dilations will be enlargements if your scale factor is larger than 1. So anything bigger than 1, even if it's 1.1, is going to make your figure larger, at least by a little bit. There are reductions as well, so we can shrink shapes down if your scale factor is smaller than 1, and what I really should have put in there, but greater than 0. There are no negative scale factors. In order to reduce size, we want it to be a decimal or a fraction between 0 and 1. Now, I specify that is because some decimals and fractions are not between 0 and 1. So let's talk about how this looks. So example 1, I said we have a scale factor of 2.8, and what the question is going to ask you on the slideshow is that going to create an enlargement or a reduction? So you use these rules here. So 2.8, even though it is a decimal, it is larger than 1. So this one would make an enlargement. Okay, and so just by giving the scale factor, you have an idea of what's going to happen to whatever shape you dilate. Okay, so this scale factor is 0.8. That scale factor is less than 1, but greater than 0 still. And so since it is less than 1, this is going to create a reduction. So if it were a triangle, it's going to reduce its size by 0.8 here. Okay, it's only going to be 80% of what it started. The third example is a little trickier because right away you see a fraction and you think, oh, definitely fraction's going to reduce the size. The fractions are less than 1. But you have to look carefully here. This fraction, the numerator, is larger than the denominator, meaning this is not actually less than 1. If you divide this out 10/4, what you actually get, and we can reduce it, but we would get 5/2. That's the reduced still. This is going to be larger than the bottom. So 5/2 is really 2.5. And so that's actually bigger than 1. So this, even though it doesn't look like it in the beginning, it is an enlargement. So what you're looking for in fractions, if they give you a fraction, if that numerator is bigger than the denominator, it's going to be bigger than 1 and it's going to make an enlargement. Okay, so that's the first section we wanted to go over with you. The second section is of dilation. So when we did this in class, we graph them. And we put these points, these would be your original points, and we would graph them. And then we were given a scale factor. We would find the new coordinates and graph them as well. And you could easily see, wow, this made a dilation because it would keep its same shape and either make it larger or smaller. With the limitations of being online, we really don't have a way to get you to do graphs online at this point. So what we're going to focus on is the coordinates. So if you have the coordinates, x is 0, 1, y is 2, 5, and z is 3, 7, and I ask you to dilate that shape by a scale factor of 5, what would the new coordinates be? Okay, so first of all, a new coordinate looks like this. X turns to x prime. Many of you probably remember that. And what we do is we multiply the coordinates by the scale factor. So 0 times 5 is still 0. That one doesn't change. But 1 times 5 is 5. So x prime would now go to 0, 5. Y prime, for this one, we would multiply each by 5 still. 2 times 5 is 10, and 5 times 5 is 25. Good thing we're not graphing these, huh? We would have quite the graph. Okay, and finally z. Z prime, if we multiply both of these by our scale factor of 5, 3 times 5 would be 15, and 7 times 5 gives us 35. And this is where, if we had a graph, we would put them back on, and it would be clear that our figure would be 5 times the size of the original. And it has to be a triangle because there are only 3 endpoints. Okay, so that's how we would do a scale factor of 5. So this is clearly an enlargement here. This is greater than 1, so we knew it would be, and it's 5 times larger than what it started. Now, what about if I did the same coordinates, but the scale factor was 1/2? Okay, we know from our rules that this is less than 1, so this should reduce the size, okay? And it's also going to reduce the numbers. The same process goes into play here, okay? So we're going to separate this, I'm going to make this in a different color. But if we start here, our x prime, 0 times 1/2 is still 0 again. 1 times 1/2 is 1/2. And if we go to y, and if you're using a calculator here, don't forget, when we type this in, and I'll use this with y, to do 2 times 1/2, you would type this in your calculator, 2 times 1 divided by 2. Remember, a fraction is just division. So if you're typing that in, 2 times 1/2 is going to be 1. 5 times 1/2 should give you 2.5 or 2.5. If you have a decimal, you may use the decimal. If you'd rather have it in a fraction, 2.5 is the same as 2.5. All right, last but not least then, z prime, if you type 3, okay, you would type 3 times 1 divided by 2, and you get 1.5, or as a fraction it would be 1 1/2. And finally, 7 times 1 divided by 2, or 7 times 1/2, would give you 3.5, or 3.5. On these assignments, if you use a fraction, it's fine. You may also use the decimal feature, depending on what calculator you have. Most of them won't type fractions in, but you can always do the division. Okay, so this is clearly a reduction. All of these numbers are lower than the originals besides the 0. The 0 is the only one that will remain the same. Hopefully this was a good review of scale factor and dilation for you all. If you have any questions, please email me or your math teacher, and we will do our best to get back to you as soon as possible. Hopefully everyone is staying safe and healthy and sane, and we will talk to you all soon. Good luck. Have a great rest of your day.